Welcome back, students. In this video, we're going to cover Module 5, Topic 3. This is Part 1 of Proving Triangles Congruent. Part 2 will be in the next video. That'll be Topic 4. But for Topic 3, Part 1, our standards are going to be GR 1.2, prove triangle congruence or similarity using side, 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 angle, side, angle, side, angle, 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 side, and angle, angle, and hypotenuse leg. GR 1.3, prove relationships and theorems about triangles. Solve mathematical and real-world problems involving postulates, relationships, and theorems of triangles. And GR 1.6, that's solve mathematical and real-world problems involving congruence or similarity in two-dimensional figures. The objective for this topic, you guys are going to use SSS, or side, 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 and SAS, side, angle, side, to prove triangle congruence. So we're actually going to talk about all four that were mentioned in, well, the first four, mentioned in GR 1.2. But Part 2, we're going to go more into the second two of these. But for now, we're on page 10 of the Module 5 packet. We have the bell ringer in front of us. If you'll pause here, please try to work out these 5 problems. Once you're done, unpause. I'm going to wait 3 seconds and then I will continue. Okay. All right, so we're on page 10. Determine whether each pair of angles or line segments is congruent, right? Yes or no. All right, so number 1 says angle ABC. So ABC is right here, and XYZ over here. So notice that ABC is 40 degrees. XYZ, we don't know. We have this side. Now notice these two angles come from this one straight line. The straight line is 180 degrees. Of course, it's 180 degrees on the other side. So XYZ is going to be 180 minus 140, or it's also 40 degrees. So for number 1 here, that is yes. All right, number 2. Line segment FG, that's it here, and DE, it's here. So FG is 4 centimeters, DE is 6 centimeters, so that is no. To be congruent, obviously, equals... They have to be equal. Well, they're not equal. All right, OR is right here, and OS is right here. OR is 2 inches, OS is 2 inches. So that is a yes. All right, number 4, angle 2 and angle 4. So angle 2, angle 4. So notice these are vertical angles. These are made by 2 intersecting lines, and the angles that are on top of each other, so in this case 2 and 4, are congruent. So this would be yes. And for these, 1 and 3 would also be congruent, just while we're talking about it. All right, number 5. ROQ, so ROQ and ROP. ROP. All right, so we notice, so here's our vertical angles here. So this guy's 90 degrees. Well, these two have to be congruent, so this one's 90. And these two across each other would be congruent. Well, since this is a straight line, these two would be supplementary. So if this is 90, the only way to make 90, to make 180, if one of it's 90, the other one has to be 90. So all 4 of these are actually 90 degrees. So that's yes. All right, moving down the page, still on page 10. Get this all on the screen here. All right, proving triangles congruent. You can prove 2 triangles congruent by showing that all 6 pair of corresponding parts are congruent. Now, 6 parts. So the parts, triangles have 3 sides. Triangles have 3 angles. That's your 6. Your 3 angles and your 3 sides. All right. However, it is possible to prove 2 triangles congruent using fewer pairs of corresponding parts. We're going to focus on 2 today, and explore more postulates and theorems to prove triangles congruence over the next 4 lessons. So we're going to talk about 4, but we're only going to practice 2. And the next part of this topic 4, we're going to talk about these 2 in more depth, or we're going to practice those, talk about them again, then practice. So postulate 5.1 says, if 3 sides of one triangle are congruent to 3 sides of a second triangle, then the triangles are congruent. So that would be, so we're going to do, actually, if they were all congruent, well, we're just going to do it like this. Just bear with me. So all 3 sides, and this is side, side, side. And the congruent marks, those are the corresponding. So this would correspond with this, the 2 would correspond with the 2, and the 3 with the 3. Same thing with angles. If they have an arc, 1 goes with 1, 2 goes with 2, 3 goes with 3. So postulate 5.2 is side, angle, side. If 2 sides in the included angle of one triangle are congruent to 2 sides in the included angle of a second triangle, then those triangles are congruent. So what that is saying, we have a side, we have an angle, and we have a side. So notice it's the 2 sides and that the angle those 2 sides make, so the included angle. So side, angle, side, side, angle, side. All right, postulate 5.3. If 2 angles in the included side of one triangle are congruent to 2 angles in the included side of another triangle, then those triangles are congruent. So what this looks like. So I'm going to, instead of just putting the, well, that's all right. Never mind. Talking to myself, as usual. So this is what this looks like. The 2 angles in the included side. So the side that they share. So you'll always see it in the middle when it's angle, side, angle. All right, and then finally, and I'm going to draw this first, or put in my colors first, I should say. There's not a whole lot of drawing happening. All right, so 2 angles in the non-included side of one triangle are congruent with 2 angles in the non-included side of the second triangle, then those triangles are congruent. So notice up here, angle, side, angle, the side is in between the angles. Angle, angle, side, the side is not in between them. It could be on the left, it could be on the right. I just put it on the right, but it won't be in between the 2 angles. Okay, let's flip over. Page 11. Readjust here. Actually, let me zoom out just a little. Okay, excuse me. So, page 11, number 1 on the left. And we're using triangle congruence, postulates, and theorems. Number 1, is there enough information to prove that the following pairs of triangles are congruent? If so, state the postulate that proves it. So we're going to start with A. So up here they give us R with 1 arc. Same thing with S. So R and S correspond. They give us Q with 2 arcs and U with 2 arcs. So those correspond. Excuse me. And then they have a 1 congruent dash there for QR and 1 for SU. So those correspond. So we have an angle. We have an angle. We have a side. And we have an angle. So yes, they are congruent. And it's angle, side, angle. Okay, B. Looks like H has a single arc, J has a single arc. We have a side here and a side here. So, are these congruent? We don't have 3, we only have 2. Oh, but wait a minute. I'm just going to highlight this. Or put yellow, whichever. Either way. So HJ belongs to both of these triangles. So, and it's congruent to itself through the reflexive property. So now we have a side, an angle, and a side. Again, yes. But you have to know that we have to, these rules in little tricks like this, you've got to remember that this belongs to both of those triangles. Otherwise, we would have said no because we only had 2 things that were congruent. All right, part C. QR has a mark. ST has a mark. We just talked about this, so I hope you guys already thought about this line in the middle. Belongs to both triangles. It is congruent to itself because it's reflexive. So we have a side and a side. But we don't have 3. So this one is not congruent. All right, number 2 on the right. I'm going to scoot over just a little. This is a you-do, so I'm going to pause right here. You pause right here. Try to work this one. Just very similar to number 1. I'm going to wait 3 seconds, and then I'm going to continue. All right, number 2, page 11. Is there enough information to prove the following pairs of triangles are congruent? If so, state the postulate. So I'm just making my corresponding parts. So my 1, 2, and 3 different colors because it's just easier to look at and see what's going on. So we notice we have a side, we have a side, we have a side. So yes, we have congruent triangles for this, and it's side, side, side. Hopefully you got that. All right, part B. So let's see. XZ and PR are both 1 mark. YZ has 2. QR has 2. Well, these angles don't have a congruent mark, but they both have a measurement. Both of those measurements are 59, which makes those congruent. So now we have a side, an angle, and a side. A side, an angle, and a side. So we do have congruent triangles, and it's because SAS, side, angle, side. All right, C. So notice we have a box. Hopefully you already know automatically when you see that box, that's a 90-degree angle. We should be getting there by now, guys. So E and A both have 1 congruent arc. And then BC and CD. So do we have 2 congruent triangles? Yes, we do. We have an angle, and a side. An angle, and a side. Okay. All right, let's go move down. Number 3 and 4 at the bottom of page 11. Let's see if we can get all this in the screen right here. Oh, excuse me. Whoa. Rocking and rolling there for a minute. All right, number 3 on the left. Prove the triangle QRT. So QRT and SRT. So SRT are congruent. They give us that QRS is isosceles and that QR is congruent to SR. So QR is congruent to SR. And that RT, this line, bisects QS. Bisects. Hopefully by now, that's another thing you know when it says bisects, it knows RT is going to cut that into 2 equal pieces. I also hope you remember that isosceles it has 2 congruent sides and 2 congruent angles, but we'll get to that in a minute. So, all right, now we're looking, we've marked what we have here before we've started down here, but we've got our word bank. So let's look. So triangle QRS is isosceles with QR congruent to RS, SR, either way. So, and that was given. That off? Given. All right, RT bisects QS at point T. RT bisects, so this was also given. All right, so we're going to move over here before we move down. So it says RT is congruent to RT. So again, this guy, hopefully you saw that, it belongs to both triangles. It is congruent to itself. And that is because that's reflexive, the reflexive property. Hopefully you guys remember that as well. All right, so now we're here. QT congruent to ST. We've already marked that. Oh, because it bisects, RT bisects QS. That's a definition of a segment bisector. So I'm going to just cut that short of SEG bisector. There we go. All right, and lastly, QRS is congruent to SRT. So not QRS. It should be QRT is congruent to SRT. Oops. Yeah, like it says it right there, but it's wrong here. Okay. So these two are congruent. How? A side, and a side. Of course, that's all that's left in the word bank. Yeah, if you follow along, it gets to where you don't need the word bank as much, but lean on it while because you have it, guys. But if you stick with me, you may not need it. All right, number 4 is a you do. Please pause here. Try to work this proof. I'm going to wait 3 seconds. Once you're done, let's see how you did. All right, number 4, complete the proof. So let's mark our stuff before we even look at this. Hopefully you guys can get in the habit of this. So AB is congruent to AD. AB, AD. BC is congruent to DC. BC, DC. And we're supposed to prove that these two triangles are congruent. So before we even look down here, please notice, right, just one more time. There we go. Please notice for me, AC belongs to both triangles. So before we even look down here, we're just going to go ahead and mark it. Okay? All right. Number 1, AB is congruent to AD and BC is congruent to DC. Well, that was our given. Again, I don't even look at the word bank. All right, number 2, blank and blank. Well, what else did we need to prove that? That AC is congruent to AC. Ah, it's in the word bank. Cool. And it's reflexive. And lastly, how are they congruent? We have a side, and a side. And that's great because that's the last thing left in the word bank. All right, let's flip over to page 12. All right, I'm going to back this up, and I'm just going to tell you guys up front that I'm going to shortcut this a little bit because if I did all the math and the whole deal, it would make the video too long. So I'm going to go into this real quick. I know number 6 is a you do. I'm going to try to do them together just to cut down time. So number 5 on the left, triangle JKL has vertices and gives us those coordinates. Triangle QNP has vertices and we get those coordinates. They're asking us if those two triangles are congruent. They ask us to graph the triangles. It says to make a conjecture and support your conjecture. So what we have to do here, we've talked about conjectures, but we really haven't talked about making them. So to make this conjecture, we're going to graph our triangles. Then we're going to use the distance formula to check the length of the sides, and that's how we're going to prove they're congruent or not. I'm going to try to make this fit into this page. We have to get creative. So first things first, let's graph. So J is 2, 5. So 1, 2, 1, 2, 3, 4, 5. K, 1, 1, 1, 1. Okay. L, 5, 2. 2, 3, 4, 5, 1, 2. And I'm sorry, I would like to show you guys all the way plotting the points, but you see, I can't draw worth anything. But it's hard to draw and get out of the way for the camera and all that. So here's JKL. All right. So Q is at -4. 1, 2, 3, 4. +4. 1, 2, 3, 4. Q. Get I had that one right, but had Q. Yeah, -4, +4. Yeah, I went the other way with it. Okay, that's what I did. And P is -7, 1. So 1, 2, 3, 4, 5, 6, 7, and we're up 1. So yes, I had it pointing down that way. When you guys look at this, so a handful of you that watch the videos, you're like, man, he messed this thing up. Well, sorry. There we go. Okay. So we graphed our triangles. Yeah, so our conjecture is gonna be, now the triangles, they gave it to us as JKL is congruent to QNP. That's how they gave it to us, okay? Sorry, my first triangle is not very good. So these sides will correspond. So JK is going to be congruent to QN. This is our conjecture. KL is going to be congruent to NP. If you can look at the graph, but just showing you here. So an LJ is going to be congruent to PQ. Now, how we're going to support that conjecture. I'm only going to do one of these sides. That's why I'm cutting down, but I'm going to do JK. I'm going to prove that JK is congruent to QN. So let me put my points here so you guys can see them. J is at 2, 5. K is at 1, 1. Just a second. I'll write the other one in pencil. What did we say? QN. Yeah, so Q. Let me see that. Okay, yeah. Q is at -4, 4. And N is at -3, 0. So our x1, y1 is going to be right here, x2, y2. So we can do that for both, all right? The distance formula, I'm going to write it above here. The distance formula is the square root of y sub 2 minus y sub 1 squared plus x sub 2. Gotta hit myself. Excuse me. X sub 2 minus x sub 1 squared. So see, we're already messing with space here. So JK is going to be your y1, y2 is negative 1. I'm sorry, 1 minus 5 squared plus 1 minus 2 squared. And here 1 minus 5 is 4. 1 minus 2 is negative 1. 4 squared, negative 4 squared is 16. 1 squared is 1. So JK is square root of 17. Sorry, I got a little. So now, go over here and do QN. Yeah, we're going to be on space here. That's all right. Well, yeah, let me do this real quick. So, just put it down here. QN y sub 2, 0 minus 4 squared plus negative 3 minus negative 4. So we have negative 4 squared plus negative 3 minus negative 4. That's like 3 plus 4 because the two negatives cancel out. So we have positive 1 squared. Oh, that looks familiar. Negative 4 squared is 16. Knew that was going to happen. 1 squared is 1. So QN also equals the square root of 17. So they both equal. So that proves our conjecture. You would want to do all three of those, but for the sake of space and time, I'm doing the one. All right, number 6 is the same thing. Please pause here. Go ahead and graph the triangles. It's going to be the same thing. It's just ABC and EFG, so those correspond that way. Your conjecture is going to be that the sides are all equal, and then we're going to, for the sake of the video, I'm going to do one side. You're going to need to do more than one because there is a part C to this question, but pause here. I'm going to wait 3 seconds. Okay. Number 6, triangle ABC has vertices. A is at 1, 1. You can see that. Yeah, okay. B is 0, 3. 1, 2, 3. Well, that eliminates my A. Okay, put A here then. B here. And then C is at 2. 1, 2, 5. 1, 2, 3, 4. I did it again. Oh, geez. There we go. We can still kind of see. And B was right there. C is right there. Okay. EFG. It's going to be 1, negative 1. 1, 2, negative 5. 1, 2, 3, 4, 5. And 4, 4. 1, 2, 3, 4. Negative 4. 1, 2, 3. Now notice here, 1, 1, 1, negative 1. This is 2, 5, 2, negative 5. I can already tell you that these guys are going to be congruent. But for the sake of our problem here, we're going to go ahead and do the math, at least with the one side. All right, so our conjecture, and again, I'm space here. We're just going to pick AB, and EF. AB congruent to EF, that's our conjecture. We're going to, well, let me move down so we can see this. And at the bottom, so part C is asking us A, B, C, or D. Are they congruent? Justify. No, these two aren't. No, because these two. And then C is yes, D is yes. So actually, they want A, B. They're talking about AC or BC and FG. Let's do. Well, we'll do BC, and we're going to do FG for sure. We'll do BC. How about that? Let's just, we can, that's fine, but we can also say BC is congruent to FG. So BC, FG. So they just went to the next one. All right. BC. So our coordinates, just going to have to trust me, but just take make A your x1, y1, B your x2, y2, E, F your x1, y1, G your x2, y2. Okay, so it's going to be 3 minus 1 for the x's, and for the y's, and for the x's, there's going to be 0 minus 1. Okay, so 3 minus 1 is 2. 0 minus 1 is -1 squared. 2 squared is 4. 1 squared is 1. So BC is the square root of 5. All right, so FG is going to do like we did before here and try to conserve space as much as I can. So F, your Y was -5 minus our, no, I'm sorry, that was, we got to go, G is our, we got Y2, sorry. So -4 minus -5 squared plus the x's are 4 minus 2 squared. So -4 minus -5, so that's -4 plus 5, that's +1 squared plus 4 minus 2 is 2 squared. 1 squared is 1, 2 squared is 4. And I think I told you guys wrong in class because I said no, but you know what? Sometimes the teacher's wrong. So BC and FG both equal 5, which I said at the beginning it looked like they were, but I remembered we thought we said B was the answer, but it looks like corresponding sides have the same measure. Yes, all corresponding sides. Well, yeah, we'll do this one because we only did the one side, but either way. All right. Flip over. See, we got page 13 left. I wasn't sure if we were done or not. All right. Page 13, number 7, top of the page. And this is it for this particular topic. Excuse me. All right, playground. The playground equipment shown appears to be made of congruent triangles. If KL is congruent to LM and JLK is congruent to angle JLM, write a 2-column proof to prove the two triangles are congruent. So it's hard to see. This was colored, but we don't have colored copies. So let me just highlight as best I can with this poor pencil that needs to be sharpened. So you can see this is J, this is J, this is L, this is K, and this is M. Hopefully. All right. So he told us KL is congruent to LM. So KL is right here. LM is right here. That's the statement 1, and it's given right here. Angle JLK, trying to make this as visible as possible. JLK, so this side, and JLM, this side, are congruent. That was also given. So now, it says JL is congruent to JL. Well, before we even look over here, you know that's reflexive because we're talking about something being congruent to itself. Let's see. So JL is congruent to itself. So now this is really hard to see. So we have a side, an angle, and a side. A side, an angle, and a side is one of the two things we had left. So that's right. But yeah, side, angle, side. That's how they're congruent. All right. Number 8. And I don't know that these say you do, I do. So, well, I'm going to do number 8. Oh, look good. We got 7 and 8 at the bottom again. Oh, Lord. All right. So I'm going to do this number 8. And then number 7 at the bottom. And then number 8 will be a you do, the second number 8. That's not confusing at all. We'll pause down there. So number 8, this one. The kite shown appears to be made of congruent triangles. Okay, you can't see it, but the line in the middle. And wouldn't you know, that's going to be the line that belongs to both triangles. So it's just fitting that I have to do that. So if DE is congruent to FE, so DE and FE, I'm just going to go ahead and, well, we'll get back to that. And EG bisects DEF, so you gotta know what that means. EG bisects this angle, so this side and this side are congruent. Then prove that the two triangles, DEG and FEG, are congruent. So our given was DE and FE. It was given. Our second given was EG bisects DEF. So the third one, we're looking for a statement. It says definition of angle bisector. Okay, well, we know this cut that angle in half. So what would we need? Oh, DEG is congruent to FEG. There we go. Okay. All right, number 4 is blank blank. So we have left, these two are going to be down here because that's where we're going to prove the triangle congruent. Reflexive. Oh, we got that guy in the middle. And there it is. EG is congruent to EG. Line segments. That is reflexive. And lastly, the two triangles are congruent. Is it side, 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 or side, angle, side? Well, before I even look over here, I know we dealt with an angle. Food for thought. But we have a side, we have an angle, and we have a side. A side, an angle, and a side. Hopefully, if you guys are paying attention, if you're watching the video, I hope we're starting. Some of this is starting to stick a little bit. I know it's a lot. All right, number 7. Again, bottom. So see, we got a box. Again, I hope you guys are picking up. That is 90-degree angle. Give us one slash there for BC and for DC. And then angle A and angle E both have an arc. So, which congruence criterion would you use to prove the two triangles congruent, and why? First off, we have, let's see, we have an angle, and a side. We have an angle, and a side. So it's angle, angle, side. And then how can this congruency be stated? So they say A, B, C. So A has this. E has this. One arc. B is a blank angle. D is a blank angle. C, and I knew it was the other one wasn't blank because of the boxes, but C has the box, C has the box. So triangle ABC is congruent to triangle EDC. Hopefully that makes sense. All right, number 8, last thing of this topic, problem, excuse me. Please pause here, try this, and unpause, see how you did. I'm going to wait 3 seconds. All right, number 8, bottom of page 13. So, which congruence criterion would you use to prove the two triangles are congruent, and why? I'm just marking my one arc, one slash, two arcs. So, are these congruent? Oops. An angle, and a side. Say 1, 1, 2. Angle, angle, side. Angle, angle, side. Angle, angle, side. How can this congruency be stated? So this is QPR. Q has the 2. U has the 2. P blank, T blank. R has 1 orange. S has 1 orange. There you go. You guys have any questions, especially with the distance formula? I know we only did the one side. Come see me if you need help or send me a message. Till next time, have a good night.